This video is on complex fractions. 4 rational expressions. Complex fractions are fractions with more than 2 levels. So for example, 2/3 over 4/7 is a complex fraction. There are 2 ways to simplify complex fractions. Method 1 is to simplify the numerator as a separate problem and then the denominator as a separate problem. And then treat this middle bar as a division, which it is, converting it into a multiplication by the reciprocal. To do it this way, we can look at this following example. You would treat the top, the 3/4 plus 2/3, as a separate example, and the 3/5 minus 1/10 as another example. So how do we add 3/4 plus 2/3? Well, we need a common denominator to add any fractions, so that common denominator is 12. The 4 here is missing a 3, and the 3 here is missing a 4. So you get 9/12 plus 8/12. And so that's still in the numerator there. 9/12 plus 8/12 is 17/12. Okay, so we've done the top, and now we're simplifying the denominator. And so our common denominator is 10, so we need to multiply the 3/5 by 2 to get to 10, which gives us 6/10 minus 1/10, which is 5/10. So now we just treat this middle bar as a division, so really we have 17/12 divided by 5/10, and to convert that division to a multiplication, we take the reciprocal of the second fraction, and we can now factor and simplify. So are there any common factors? Yes, the 12 and the 10 can divide by 2, leaving us with 5 and 6, and the 5's divide by 5, giving us 1 and 1, leaving us with 17/6. So that's one method. The other method would be to get all the fractions into a common denominator. Notice in the first method, you looked at the numerator and the denominator separately. This denominator had a denominator of 12, this denominator had a denominator of 10. However, if you find a common denominator for all of them, then what you can do is you can treat this fraction and also multiply top and bottom by that common denominator to eliminate it. Okay, so let's get everything into the same denominator, and that denominator is going to be 60. So the 4 needs to be multiplied by 15, so that's 3 times 15 over 4 times 15. The 3 needs to be multiplied by 20, which is 3 times 20, 2 times 20, and the 5 needs to be multiplied by 12, 3 times 12, and then minus the 10 has to be multiplied by 6, so 1 times 6. So that leaves us with 45 over 60 plus 40 over 60 over 36 over 60 minus 6 over 60. So now we can actually multiply the numerator and the denominator by 60. But in doing so, we're actually multiplying each bit by 60. So then we actually, in dividing, are left with 45 plus 40 over 36 minus 6, which is 85 over 30. Notice we couldn't simplify anything here when we had our pluses and minuses, but we can simplify here because everything is combined in numerator and denominator. So let's see what we can divide here by. We can divide by 5, leaving us with 17/6. So here's an example. We can employ either of those methods previously described. So which method would you like to use here? Try it out and then see if your answer matches this answer, even if you did it in a different way. So in this case, you could just say, oh, we're done with the top, there's nothing to do there. And in the bottom, we need a common denominator, which would be AB. So multiply the first fraction by B, the second fraction by A. So that leaves us with B over AB minus A over AB. So we have A minus B over B minus A over AB. And notice I'm employing the first method. So keep this first bit in brackets because it's held together. And so now that leaves us with A minus B divided by B minus A over AB. So that turns it into A minus B over 1 times AB over B minus A. But now we have no common factors except the A minus B actually looks very similar to the B minus A. If you recall, it's really easy to flip the B minus A into an A minus B if we factor out a negative. So essentially we'll have A minus B over 1 times AB over negative bracket A minus B. And now these can cancel out, but don't forget your negative. They cancel out because A minus B divided by A minus B is 1 over 1, but this one's a negative. So the negative is still there, and we've got negative AB. Here's another example. Let's try the second method in this case. However, make sure you employ the use of brackets anytime you have stacked fractions like this. So what is the lowest common denominator for all of the denominators in all the fractions here? Well, we need an x and we need an x plus 2, and that's it. So let's make sure all of them have that. So we've got x times x plus 2, and that needs another one up there. Another tip is to leave a lot of space when you write out a question so you can have space on your page to put these extra bits in. So here we'll also multiply by x. Here we need an x plus 2, an x plus 2, and an x and an x. So you'll notice we actually have x plus 2 squared minus 1x over x times x plus 2 on top, all over 5 times x plus 2 plus x squared over x times x plus 2. Now we can multiply the numerator and the denominator by x times x plus 2. We're allowed to do that for this big fraction, and that will actually eliminate our denominators. Now that step, if you just actually took this and used it as a division, you'd notice that the top multiplied by the flip of the bottom, this bottom and this would be in the bottom and this would actually be in the top when it flips, so they'll actually cancel that way as well. So essentially we're left with x plus 2 squared minus x over 5x plus 2 plus x squared, however we do it, and we need to expand that and continue. So let's continue that. We've got x squared plus 4x plus 4 minus x over 5x plus 10 plus x squared. When you expand something like that, you want to keep brackets like that. However, in this case, we just have a plus in front or nothing in front, so those brackets won't be necessary. So let's combine any like terms. We have x squared plus 3x plus 4 over x squared plus 5x plus 10. Let's see if we can factor those any further. So in the top, can we get a product of 4 and a sum of 3? Well, to get 4, it's either 1 times 4 or 2 times 2. To get a sum of 3, well, neither of these add to 3. Because of this positive here, we actually cannot factor the numerator. The denominator, can we get a product of 10 and a sum of 5? Well, 1 times 10 or 2 times 5 are the product options, but neither of those add to 5. So because neither of those factor, then we are complete. Here's another example. If you have negative exponents, then you should convert each one separately into a fraction first. So we've got 1 over x squared minus 1 over y squared over 1 over x to the 1 minus 1 over y to the 1. And now we can go on and either use method 1 or method 2. So let's get them all in the same denominator. So a common denominator for all 4 of them would be x squared y squared. So this one is missing a y squared. This one's missing an x squared. This one's missing an x and a y squared. This one's missing a y and an x squared. So that leaves us with y squared minus x squared on top over a common denominator of x squared y squared, and xy squared minus yx squared over a common denominator of x squared y squared. So we can multiply numerator and denominator of the big fraction by x squared y squared and eliminate our denominators, leaving us with y squared minus x squared over xy squared minus yx squared. So now we need to simplify that. Y squared minus x squared will be y minus x, y plus x factored. And the denominator has a common factor of x and y, leaving us with y minus x. Now we have a common factor of y minus x, so we've got y plus x over xy left. Now you could split this up into y over xy plus x over xy, which then would simplify to 1 over x plus 1 over y. So if you wanted to have it back in negative exponents, that'd be x to the negative 1 plus y to the negative 1, but we generally do not want our answers in negative exponents. And here's another example. Again, let's get them all in the same common denominator, and that would be xy. So here you're missing an x, here you're missing a y. So we actually have x squared minus 16y squared over xy over x minus 4y over xy. If we multiply both top and bottom by xy, our denominators are gone, and we have x squared minus 16y squared over x minus 4y. So if we factor the numerator, there's no common factor, but we can make it x minus 4y, x plus 4y by the difference of squares, and we actually have x minus 4y in the denominator as well. So that disappears as a division into 1 over 1, leaving us with x plus 4y as the simplified form.